Hello everyone, in this video we will learn about the logarithmic function context and data modeling. Alright, so logarithmic function models for a given set of data. If the input values appear to change proportionally over equivalent input value intervals, then a logarithmic model is appropriate. Alright, so a logarithmic function model has the form y equals a plus b times natural log of s, or y equals a plus b times log s. Now keep in mind, natural log of s is the same thing as log base e of s. Now log s is the same thing as log base 10 of s, where a and b are constant and b must be different from 0, right? Okay, so let's take a look at the first example. Selected values of the logarithmic function L are given in the table above, where L of s is a plus b natural log of s. Use the given data to write two equations that can be used to find the values for the constant a and b in the expression for L of s. Alright, so basically you have s equal to L of s equals 3, right? So you substitute over here, this guy is 3 and this guy is 2, right? So you have the first equation, a plus b natural log of 2 equals 3, right? Now the second equation, s equals 5 and L of s equals 7, right? So this guy is 7 and this guy is 5, right? So you have a plus b natural log of 5 equals 7, right? Now find the value of a and b. Alright, so basically you just solve a system of these two equations, right? So basically you just do elimination method, right? So I'm gonna subtract this guy vertically. A subtract a is gonna be 0. B natural log of 2 subtract b natural log of 5 equals 3 subtract 7 is going to be negative 4, right? Now I need to factor b out. So this guy turns out to be b times natural log of 2 minus natural log of 5 equals negative 4, right? Now I'm going to divide both sides by natural log of 2 minus natural log of 5, right? So b equals negative 4 divided by natural log of 2 minus natural log of 5, right? Now we're gonna print up the calculator to calculate the value of b, right? So we're gonna hit add calculator and we have negative 4 divided by parentheses natural log of 2 minus natural log of 5. And then you just hit enter, right? So it gives you the exact form right here. You need to convert it to decimal if the question wants you to do it, right? So you hit menu, number, convert to decimal, right? And then you hit enter. The answer is 4.365, right? So it could be approximately 4.365. Now you need to solve for a. So you substitute b back into one of these two equations right here. You solve for a. So for example, I'm going to substitute this guy into the first equation. So I have a plus 4.365 times natural log of 2 equals 3, right? So I subtract both sides by this number, right? So a equals 3 subtract 4.35 natural log of 2, right? So then I'm going to print up the calculator. So I hit 3 subtract 4.35 times natural log of 2, right? And then you just hit enter. The answer is negative 0.0256, right? So it's approximately negative 0.0256. Now let's move on to example number 2. Given the table of data. Alright. Question A. Use the regression capabilities of your graphing calculator to find a logarithmic function model for the data above of the form S of B equals A plus B natural log of P, where P represents the just sign, right? So this guy is P. And S is the average pastor salary, so S right here in thousands of dollars, right? So we're going to print up the calculator. Now I'm going to show you 2 different ways to do it using 2 different calculators. First, I'm going to use the TI-84 calculator, right? So I'm going to hit start, edit. Now L1, which means the P values, L2, which means the S value right here, right? So I need to input the value. So it's going to be 75,000. And L2 is going to be 42,175. Alright, now hit start again, go to count. Now we need the logarithmic function model, so it should be number 9 right here. So you hit number 9. Okay, L1 represent S list, L2 represent Y list. Alright, go to store right here, hit fast, Y fast, function, store S, Y1, right? Hit enter, and go to calculate. So here's the function. Question B. Using the model file in part A, we need to find the predicted annual salary when the job site is 500 people. So basically, you just substitute 500 for P, right? So S of 500 equals negative 91.542 plus 29.909 natural log of 500, right? So you hit the calculator, you get the answer. But anyway, I will show you how to calculate this one directly from the information right here. Alright, so you have 2 different ways to do it. The first way, you need to hit graph, right? The graph doesn't show up because the window range does not fit the data, right? So you look at this one, S means, which means 70, right? So you put 70 right here, so that is gonna cover this data. S mass right here, you see that 5,000, so I'm gonna put 5,500. The scale right here, I put 100. Now, Y means it's gonna be 40, so that is gonna contain 42, right? So I put 40 right here, and S mass right here, you see that the maximum 175 right here, I pick the 200, and then the scale right here is gonna be 10, and I hit graph, it's gonna be right here. Okay, so you hit second trade, okay, value number 1, S equals 500, hit enter. The answer is 94.329, right? So it could be, right, thousands of dollars. Now the second way is going to be faster, okay? Because you already stored the function, so it helps you a lot. So you basically, you just hit second, more, you quit the graph. Now you hit was y was function. Previously you store function as y1, right? If you store y2, you hit 2. If you store y3, you hit 3, right? Now I store y1, so I hit 1 right here. I hit enter, and then put parenthesis 500. And I get the same answer right here. By doing this way, I don't need to graph it. Now the second way to do this one is to use the TI spy calculator. Alright, so I'm going to print up the calculator. Right, so you're going to hit this one right here, the spreadsheet right here, hit this one. Now, you need to go up over here, you need to name the column. So I name this as value. And then the right one right here, and then this is the Y columns, right? X column represents P, Y column represents S right here, right? So I'm going to go down. Now I just input the values. So it's going to be 75. Alright, so you're going to input the values for the Y columns. Alright, so it's going to be 42, 175. After you finish inputting the value for the tables, right, you hit Control I. Right, add calculator right here. Now you hit menu, number set, start calculation, and then go to logarithmic regression right here. Hit enter. Right, as list, which means as, y list, which means y. Now remember that you store function as f1, right? And then you hit OK. And then here's the information about the table, right? A equals negative 91.542, which is right here. And B is going to be 29.9088, right? I'll round it up. Now, in order to find the value for 500 people, you just hit F, right? 1, parenthesis, 500, close parenthesis, hit enter. The answer is 94.32, right? So it's going to be right here, 94.32, thousands of dollars. Alright. Now, next one. Suppose the average annual salary for pastors in 2030 in the United States is 180,000, approximately the just sign, right? So you given S of P, right? And you need to find P right here. Now I'm going to use the formula right here. So I have negative 91.542 plus 29.909. Natural log of P equals 180,000, right? So it could be 180, right? Because the unit is going to be thousands of dollars, right? So I'm going to add 91 both sides, right? So it could be 29.909. Natural log of P equals 180 plus 91.542. And then I'm going to divide both sides by 29.909, right? To solve for natural log of P. So it could be 180 plus 91.542 divided by 29.909, right? So I'm going to print up the calculator. So it's going to be 180 plus 91.542 equals, and then divide by 29.909, right? So the answer is 9.079. 9.079. Alright, so I know that natural log of S equals A. It's the same thing as log base E of S equals A, right? So in order to solve for s, I'm going to draw an arrow right here. So s equals e to the a, right? So I'm going to apply this one. So it could be, this one is the same thing as log base e of p equals 9.079, right? So I'm going to draw an arrow right here. So p equals e raised to the 9.079. You can leave the answer like this. It's fine. Or you can print up the calculator. You hit e to the s right here and you input 9.079. So the answer is going to be 8,769.19, right? Now let's move on to the next example. Alright, so the most common and preferred method to measure sound intensity level is in decibel. The sound intensity level beta in decibel. So this one can be written as beta. Alright, of a sound having intensity I in watts per meter square is modeled by the function beta of I equals a plus b log base 10 of I, right? Where a and b are constant. Now, the sound noise traffic has intensity, so this is I, right? Equals this. And then beta is 70 decibels, right? If intensity is I equals 1 and then beta equals this one, right? Now use the given data to write two equations, right? So the first equation we have A plus B log of I equals 1 times 10 to the negative 5th equals 70 right here, right? Now the second equation, A plus B log of I equals 1 right here, right? And then beta equals 120. Now question B, find the values of A and B, right? Now I just do subtraction, right? So A subtract A is going to be 0. This guy subtract this guy. So I have B log 1 times 10 to the negative 5th subtract B log 1 equals 70 subtract 120 is going to be negative 50, right? Now I cut the B out. So B times log 1 times 10 to the negative 5. So I just write 10 to the negative 5. I don't need to write 1 times, right? Because 1 times this one is going to be itself, right? Minus log 1 equals negative 50, right? Now I'm going to simplify this one further. So it turns out to be B. Negative 5, I bring it to the front, right? Because I'm going to use the formula log base A of B power of K. You can bring K to the front. It's going to be log base A of B and then K right here. Alright, now next one, if you have log base A of A, this guy the same, the answer must be 1, right? Now, I bring negative 5 to the front, I have negative 5 log 10, right? Minus log 1 equals negative 50. Now, log 10, which means log base 10 of 10. So this guy equals 1, right? This guy equals 1. Now, log 1 has the base 10 right here, right? Now, we know that log 1 equals 0, right? Because we have the base right here, 10 power of 0 equals 1, right? Keep in mind, you have natural log of 1 is still 0, right? So keep this one in mind. So this guy equals 0, right? So I'm going to end up with negative 5b equals negative 50. So b equals negative 50 divided by negative 5 is going to be 10, right? I'm going to substitute 10 for b into this equation. Alright, so I have a plus 10 log 1 equals 120, right? But this guy equals 0, right? So 10 times 0, it could be 0, so a equals 120, right? So the answer is A and B right here. Now, question C. If you given I equals this guy, right? According to the model found above, what is the predicted number of decibels required to push a human eardrum, right? So we need to find beta equals how much, right? So we have the formula right here. It's going to be beta equals A plus B log I, right? Now we substitute the values for A and B, right? So it's going to be 120 plus 10 log I, but I equals this one, right? So it could be 10 power of 4. I don't need to write 1 times, right? Because 1 times is going to be 1, right? Alright, so I can simplify this one without using the calculator, right? So 4 bring to the front. So it's going to be 120 plus 10 times 4, right? It's going to be 40 log 10, right? Now log 10, which means 1, right? Because the base right here 10, right? So we're going to use the formula right here. So this guy equals 1, right? So it's going to be 120 plus 40. And it's going to be 160 decibels. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in